Hello and welcome to my devlog. My name is Jarmo, aka Hero Crab, and in this episode, I will present an update on my recent progress. I've just come off a hiatus of about 4 to 5 months. I spent a lot of time learning other things, developing other stuff, and playing some games, right? League of Legends. Without further ado, let's go ahead and get started. Alrighty, so I have a number of things to cover in this video. I have them itemized here. The first thing I want to talk about is this map concept that I was working with. Several videos ago, I was working on developing a map that looked more realistic. It was kind of it had some cliff faces, some grass. If you look at my YouTube, you can see that video. I was really learning a lot about developing maps, modeling, texturing, a lot of different things. I've since then shifted gears to more of a low poly map style, which I'll show here. And then I'll talk about where the map's going to go from here. The map I currently have created here is a low poly style of map with some kind of random cliff faces, if you will. I mean, they're not really random. I modeled them in Blender, and I created these map terrain components right here. And then to make this map, I just pieced them together. And then basically built 4 quadrants of the map and just rotated it, right? So I do like the way this map looks, though I don't think I'm gonna continue with it. There's a lot. Obviously, I was just more exploring this as a concept. It does look great. I may come back to it, but I have since then contracted some cliffs to be modeled, and I received those from the artist. And I'm going to go back to a more smooth style terrain with some nicer realistic textures, some very nice rock cliff faces. Probably, some water, foliage, different things like that, and then some splat maps to make kind of like worn pathways and things like that. Because this is great, and again, like I said, I may come back to this, but I still want to give another attempt at what I have really envisioned originally. So that's the low poly map. Had a lot of fun doing it. Learned a lot in Blender. Unit selection. So I've implemented unit selection, which essentially reads everything from JSON, if you will, and it will lay out all the units here, similar to the original game that it's the spiritual successor to this, which was called Command & Conquer Soul Survivor. So there'll be a bunch of units here in this panel, and you have an identity, which is your name, your team color, and the units, and then I implemented these stats, the stat readout, which changes with units. I had populated some fake units in here, but I took them out. And the green here will be the base stat that the unit starts with, and then the yellow will be the delta that it's able to scale up to in each type of stat. And then I have some versus modifiers down here. And I plan on possibly even using these same UI elements up here on top of the screen when you're inside the game so that you can see your own stats. So we'll just pick the test cube here and click OK. So here's my test cube unit. It has a chassis with an arrow on it, and then it has a turret with an arrow on it. And I guess before I go into unit control, I'll stop and talk about the chat system. I also implemented a basic chat system using a network plugin that I've created for Flax. And you get a global message just by hitting enter. And then a team chat message by holding shift and hitting enter. And I've tested this. This is actually running over the network right now on the hardware NIC. It's not even running on the loopback. And I've tested this with multiple clients. But it's all really early development stages, so no real play testing or anything like that yet. So that's the chat system. Also made use of Flax's animation player, scene animation player. So I have some nice slide in and slide out effects going on for the various pieces of the UI here in the minimap and the chat system. And then I'm kind of roughing in some option screens. But I'll just go back to the game here. Okay, so that's kind of items 1, 2, and 3 there. The next is unit control. This was a lot of work. I had to come up with, how I'm going to control the units over the network. Do I want to synchronize them? How often do I want to synchronize them? What type of netcode am I really implementing here? I settled on something which I think and this could be a very long, big conversation, but I'm not going to go there. I settled on something simple that is essentially authoritative server architecture. It's client server. It's more classic in nature. And I did that because with a previous game that I wrote with Stride, I used client-side prediction and, lag compensation and all of these things. And, I don't really know that it was necessarily worth it. What I want here is a game that plays very deterministically, and I want it to be very accurate. And in terms of what the user sees in the simulation, all of those other techniques, they actually lie to the user. They actually deceive the user into believing that the game is more responsive than it actually is. And then there's all of these little things that are implemented to hide latency and things like that. And that's fantastic and great, and that's wonderful. But for this game, the game that I'm modeling it after, it's 22 years old, or something like that, 34 years old, and it was classic client server. So I'm implementing the same thing, which means the user will experience the latency. However, it will be very accurate and deterministic for the entire duration of their gameplay, and it will essentially be quickly understood. So either they'll love it or they'll hate it. Now, because of this isometric view of this game and the way that the units will report to the player and the way that they'll move, it's actually not that big of a deal. And how can I say that? Well, I went back and played the original game and increased the latency to 500, 600 milliseconds and just played around with it. And it was still very fun to me. So that's my thoughts on that. And because of this, there's all kinds of cool things I can do with simulation and state and replay and things like that that are just seemingly easier to do with that style of netcode. Okay, so unit control. I have basically a right click to move around, WASD to scroll on the map here. I also have map edge scrolling implemented, but it's disabled presently just because I'm running in windowed mode and it becomes a pain. Then I also have the stuff that I showed off before with the minimap. So you can see here getting some frame loss or something there. But yeah, so the unit just moves around like this. It's pretty fun. The chassis and the unit itself is doing some terrain hugging. So there's no actual physics implemented here. It's all just hugging the terrain based on raycasts. And then I also have some targeting. Now this was very fun to get into. And the basics of this is I created, a system of, inheritance and all of the wonderful, lovely development tools for what I'm calling like targeting rendering, right? So this unit is using an arc rendering implementation. So if I hit control here to control fire and left click, you can see it's arc for firing, right? And it tracks with the unit moving. If I go out of range, it breaks. If I go too close, it breaks as well. And this is all, obviously stuff that's customizable. The beauty of this though is with the game being isometric and these kind of cliff faces and everything like that, I wanted to retain some of the characteristics of the original game where, most things are positionally related in the game. Now it will break the arc, like if I get too close and I target up here. You can see here where the white dotted lines are, that's where the arc is good, but then it's broken after the red. So, this round or munition would just hit the cliff face if I was to fire. There's presently no firing implemented. I haven't gotten that far yet. That'll be in a future sprint. But I'm really happy with this implementation right now. It's very easy to make this also just a straight line with the same system. And then I'm also going to implement a couple more times of a couple more different types of targeting systems that are modular and could be plugged into the units when I start designing them. Oh yeah, and one thing that was fun to do as well is, I don't know if you'll be able to see it. Yeah, you can, but the turret is actually, aligned with the arc, right? So its destination is some point up here in space, and it's doing some lerping between two different lines over time. Okay, one thing I didn't mention about the drive system, what I presently have implemented is really just, it's all simulation, right? And so it's using lerping for moving, essentially. There's no velocity, there's no physics. And so What that means is there are a couple of things that I'm going to have to work on, and I'm kind of jumping ahead. I guess I'll just touch on the mouse cursor real quick. I already went over the targeting line of sight system and the mouse cursor swapping. So I implemented some basic UI, right? If I hold control, the mouse turns red for, if I'm force firing. If I click on this unit, right, it's red over the unit because the unit is on a different team. Otherwise it's green, it's white over the UI, right? So just basic cursor functionality was implemented. And then what I was getting to here is the next two tasks. And actually this one can be deleted because I'm going to do something different there. And I already talked about the new maps, so clear that one out as well. Okay, so the next challenge that I'll be working on is collision avoidance. And why is that important? Well, the system I'm using to move units over the network is essentially, like when I click here, if I click up here, right, it's going to find a path to this unit. Now it's not going to take into account this unit. That's because the nav mesh is for the map only, and there's no way to really compute, recompute the nav mesh every tick. Wouldn't that be amazing? To account for this unit. Stuff like that doesn't happen. And so what I need to do is be able to avoid the collision with this unit. You can see here that if I don't, because it's moving over time, it's eventually just going to kind of like phase and or slide very quickly around the unit. And so you can also see it sometimes here if you just get close to kind of spam click on the unit, on the enemy unit, right? It kind of does some very rapid shifting and moving around. So what I'm thinking about doing for this is implementing some collision avoidance. There's a couple things I could do. There's lots of different ways to do it. I want to do something very simple, because essentially, there could be anywhere from 20 to 40 units in this game. So if you got, 5, 10 units all kind of clustered together, clicking around, fighting, yeah, they're going to die. Yeah, there's going to be, stuns and things like this in the game that are going to prevent some of this. It's kind of like League of Legends. If you go actually join a game of League of Legends and then just try to do stupid stuff with the collision, you can actually do all kinds of stupid stuff with the collision. So even, a premier AAA game hasn't really solved this problem in an elegant manner, or in a perfect manner anyways. But what I'm going to do probably is just some very simple collision avoidance, and I have this article here, which is understanding steering behaviors and collision avoidance. So the idea here is the unit is moving, so this red triangle would be the unit, and it's moving at a velocity. Right, as it's moving, it's got this forward vector, kind of like elongated forward vector, that's doing some, physics, or not physics, but it's in the physics subsystem, but some raycasting to detect collisions with other entities. It picks up whichever entity is the closest, and then it will calculate basically a push vector if there's a collision. So if the endpoint of that forward vector is closer than the radius is of, if the distance between the forward vector is is smaller than the radius of the circle, like for example over here on the right, then this is going to be a collision, right? And so you can take a difference between this point and this point and create a push vector and additively apply it to the velocity, so you can just kind of push off the unit. Now, I've thought about this. Here's some ways you can do this. This seems very simple to implement, and I'm kind of interested in what the other side effects that will introduce. I can already think of a few. For example, if this unit is over here on the cliff, say it's like right here on the cliff, and I'm over here, and I click like right here, and this unit says it's intersecting to the left of that unit, then this unit is going to push left essentially to get around it. Now there's one problem there of how do you additively apply the velocity and still yet lerp over time. That's going to be a real problem to solve, because the server is informing the client the time at which it needs to reach the destination essentially. And so when this kind of happens, the client, the server may need to adjust the client's timing and say, hey, yeah, you can push and get over there, but you're going to need to allow for greater time to reach the destination or something. So I haven't quite figured all that out. But there's also the possibility that this could just push off the cliff. Now, there's no physics, there's no gravity and mass being used here. But and as long as I maintain the same Y elevation, then it can kind of push and just come back, and it may not be a big deal. Then you can kind of tune the nav mesh as well. So there's some different things there to look at, but I'm excited to work on that because it's a challenging problem, and I'm not too worried about it. Like I said, it's just more of a fun problem to solve. And yeah, I think that pretty much concludes the update here. I went over these things: the map, the unit selection, the chat system, unit control, the line of sight targeting, the mouse cursor swapping, and now this new problem of implementing some collision avoidance, which is what makes game development so fun. Alrighty, thank you for watching.